Hey guys, how's it been going? Welcome back to a new tutorial. It's been a while since a new video, and no, I've been off busy with some work lately, but we are back again. And in this video, I want to show you guys how to create a simple spline tool to populate your meshes in the level. So the good thing about this tool is it uses HISM, which is really performance friendly. We'll be adding a lot of custom variables like spacing, then probably offsets, custom meshes, also like a spawn chance, let's say only 50% chance to spawn mesh, and we'll make it like 10%, will hardly spawn. Then offsets, for rotation offsets, I'll show you all how to add that as well. So now as you can see, everything has a random rotation to it. So it's a tool which you can build on, add more stuff once you know how to do this. I'm really excited to show you guys. It's a really handy tool in production. Hope you guys will find this handy. And let's start. So let's finally begin. First things first, what we do is create our actor. So for this, we need an actor blueprint. Let's name it BP underscore spline mesh spawner. Okay, you can name it what you like. Let's open it up. So before we continue, let's add few variables which we will need. So first, what I can think is the spacing, which will be a float. This will be public, so do that. Next, we need a start offset and an end offset. Okay, that is fine for now, I feel. For starting, we will add more once we progress. So next thing, compile this, give some default value for the spacing, 50 should be fine, and add a spline component, and also add an instance static mesh, hierarchical instance static mesh component. That's all we will need over there for now. Now, next thing, open up your construction script and let's begin. So construction script basically runs every loop. So first thing what we want to do is take your HISM component. I'll rename this HISM so it's easier. And what you'll do is clear instances. Okay. Also, I'll add another variable. This will be my prop mesh. Type will be static mesh. And let's make this public. All right. So next thing, what I want to do is take our prop mesh and we define is valid. So if it's not valid, we won't do anything. If it's valid, we will set it. So take your HISM again and just do a set static mesh. And connect your prop mesh to the new mesh and compile. All right. Next thing, what we want to do is get our spline length and have calculate the spacing. So for that, it's simple. Drag your spline, get spline length, And I'll promote this to a local variable since we'll be using this in a lot of places. Spline length. Connect this. All right. Now, from the spline length, we want to subtract the start offset and subtract the end offset. So just add a pin and add both of them and promote this to a variable. We will name this as a usable spline length and correct that. And from here we need the spacing. So for that, divide this by your spacing variable. Let's compile, and you want to floor. So this will give you an int return, and just promote that to the variable. This will be your number of props. Perfect. Now, next thing what we want to do is calculate the distance. So first thing, I'll just comment this spacing calculations. I always like to do this, it keeps it clean. That should be fine. All right. Now we want to calculate distance. So from this number of props, what we want is a for loop now. And your last index will be this. And now for the distance, we will multiply the index by our spacing. And let's add our start offset if needed. Perfect. Again, promote this to a variable. We will name this distance and connect this to your loop body. Compile. Perfect. Comment this distance calculation. So whenever you come back after a while, you always know what's going on where. All right, perfect. So now we have that. All that's left to do is spawn the mesh. So let's do that. So that's simple. You take your HISM and just do add instance like this. And for your instance transform, what we want to do is, okay, we'll first create a make transform node, connect this here, and for location, let's do drag in your spline component, get location at distance along spline. Connect this to location, and for distance, connect your distance variable which you made. Let the space be local. Same thing you want to do is get rotation and distance along spline. Same thing, connect that to your rotation. We'll keep the scale 111. Also, okay, I would suggest we leave a little bit of space, because later if you want to add offsets and stuff, this is where you'll add it. So I'm just adding some bit of space. All right, perfect. So before moving forward, let's just test it out. So drag in your spawner. Let's just increase this, add something. All right. Now Let's add in our mesh. I'll just add the cube. You can see, you can increase the spacing. Perfect. That's 150 is fine. And perfect. This is what we needed. And since it's an HISM, this is very much optimized and performance friendly. So, all right. Now, let's add more stuff to this tool. Firstly, let's add some, let's say, rotation offsets. Actually, I'll change this mesh as well. Do I have anything good? Let me check. Barrel. I should have downloaded some mesh. It's my bad. Okay. Okay. I should change here. Sorry. So, what's this box? Okay. This should work. All right. Next thing, what we want to do is let's add some rotation offsets. And this is perfect. If you feel it's up, you can just click the spline point and press the end key on your keyboard. It will snap to ground. Okay, now for rotation offset, other thing what I like to do is inside your blueprint add categories for spacing. Let's do setup. Your prop mesh will also come under setup. The start offset can also come under setup. So, and make it public as well. And setup. Okay. Now, let's do offsets next. Got it? So, I'll create a new variable. I'll name this rotation offsets. Type will be a rotator. Make this public. And for this, the category will be offset. Perfect. So I'll just delete this. So after this, what we want to do is break rotator, and so keep the make rotator. Now, okay, thing is this will rotate everything. Okay, what we want to do is give random rotations. So let's that to, I think, in our Z axis, if I'm not wrong. Yeah, Z axis is what we mean, but we'll add for all of them. Okay, so what I'll do is we can add roll and pitch can be the same, and for this we'll do a float, random float in range, and convert both of these into variables. Delete the rotation offset variable which we created. This is a better way. Promote to variable, we'll name this minimum yaw rot. Put that in your offset category. Next thing, also create the max to a variable. This will be your max yaw rot. and compile. Okay, let's check it out. So inside your details now, if you check, you'll get this setup, and if you come, you should have offset as well. Oh, okay. So I forgot to make the variables public, I think. So make this public, and put it into offset. Now we should be able to see it in the editor as well. Okay, let's test it out. So let's do 90. As you can see, now they have different rotations. If I do 360, then all of them will have random rotations. Perfect. Now, next thing, what we want to do is let's add a probability chance, like if you want to skip some so that it looks more random. Let's add that. So at this point, we are creating our own PCG framework. So for skip, we will add this, let's say before let's say before the loop. I think before the loop will be a good time to add the skip. Okay, let's see. Or we can also add after the loop, after we check the distance. Okay, for this, let's create a new function. I'll name this check spawn chance. We'll add an output. This will be can spawn, no, should spawn mesh. Okay, let's add a new variable. This will be your spawn chance. The type will be float, public, and let's put it inside setup as well. Let's give it the default value of 100. And for this, I will also add a slide range and a value range of 0 to 100. So that's value range. Perfect. So only thing we need to do over here is add a random float in range. So minimum will be 0, maximum will be 100. If this is less or equal to your spawn chance, return this true. Perfect. Now let's go back to our construction script, and after checking the distance, drag in the float and add a branch node, and only if it's true we will add the instance. So let's check it out. So if I go inside my setup, we already find the spawn chance. Let's make it, let's say 75. So as you can see, it's only 75%. If I do like a 50% chance, 0 will remove all, 1% will badly. It should, if I increase the spline length, it should spawn something somewhere, as you can see. If let's make it like 25%, 50%. So as you can see, it's working perfectly well. And if we do overvalue, it will automatically clamp it to 100. So you don't have to worry about like a 1000% chance or something like that. All right, perfect. And if you want to randomize it more, we can also add like your offsets for location as well, the same way. But I think I will leave that for now. I just wanted to show like an easy, like a more performance friendly way to how to create these type of meshes. If you want more stuff like random meshes or something else, do let me know. I'm currently a bit more active on creating tutorials and will be reading the comments. So yes, thanks a lot.